Fantastic. Never work with children or technology. So next up, we have Stuart Fraser from Wallet Services, who's going to talk to you about cross-chain, cross-supply chain assured manufacturing records. Please give him a round of applause.
Yep. Thank you. Cross-supply chain assured manufacturing records. I don't know who came up with that title. As you would have saw, a little bit of a problem with the presentation. This is not my usual deck, but I will do my best to tell you what we're doing, which is a little bit different. A lot of people keep talking in the blockchain space about things that they are going to do, or ways that blockchain can be used in certain industries. But I'm going to talk about the use case that we're actually building out, working in the oil and gas sector around the manufacture of high-value assets. Wallet Services, we are a small team. We are a business based, an SME business based in Edinburgh. We've been going for about 3 years now. And we are looking very much at using blockchain to solve our customers' problems. We have a wide range of experience. My background is originally in InfoSec, or I guess you guys these days call it cyber, but in my days it was information security. And across the team, we've got some good software engineers. We've got some people who really have been out and worked in the public sector, the private sector with Microsoft. We have a broad view of industry and in Scotland and the problems that they have, such that we are looking to go from the problems to the solution, rather than we've got a magic blockchain, we know how to fix your problem. We're coming from the other way, which I think is important to point out. And we're doing that with our view that the world today is built in silos of information. There's lots of good history why this has come to be. Paper-based processes originally got put into databases. Databases ended up on networks. Networks ended up interconnected. And then we started losing data. So we start to put in security controls. We've got firewalls. We've got a whole stream of technologies that are there to protect our data. Unfortunately, though, these controls then inhibit the way that we can share data in a way that is useful or productive for companies and organizations who are working together to interact in the way they need. Now, it's important to remember that there are commercial sensitivities involved in this. A wellhead has no right to be forgotten under GDPR, but you do have to maintain the records for a minimum of 25 years. And in other industries, such as nuclear, then you have to keep your records for 100 years. So it's a different set of problems that we're fundamentally looking at, particularly given that this day is both blockchain and identity. But for this case, we are looking at it, as I say, for high-value manufacturing assets. So how can a number of organizations that need to collaborate to make a thing, build a thing, and assure that it is built to a high quality? It's not just about the quality, it's about things are built in batches, things are made in collections, and you need to know where they are. So what we're looking to do is to provide a transport that provides a capability of providing the minimum data that's needed to pass between the hands of these different bodies. And in particular, in oil and gas, I'll talk more specifically about the manufacturer records book, MRB as it's known. Other industries have similar technologies or similar sets of documentation, but the oil and gas industry has been quite heavily regulated in the past for lots of good reasons. And post-Deepwater Horizon, I think people will understand that the collection of evidence that a thing has been built properly, especially when the damage that it can do when it goes so wrong, is an important thing. So we're doing that with Sticker, which is our blockchain technology. But because of the design decisions we've made as we've gone along, it's a little bit, we have certain views and opinions of data that we enforce in the system. So data is all on-chain. Any data that is not on-chain is uncontrolled data. We don't like uncontrolled data. It's good for this because we have a long lifetime to keep the data available for. Consensus is another major issue. So I make a thing, I say a thing is made. It's not up to you lot to decide that the thing is made. I am an authority for my data as it goes out onto the network. Doesn't mean that other people can't check my data, can validate that the thing has been built, and in manufacturing, that's generally the assurers, so the Lloyd's registers, the DNVs, the third-party assessors who come in and go, yep, it's wellhead, it's yellow, yep, you built it, tick, off you go. A little bit more complex than that, but essentially that's what's happening. You're paying a guy to come on site and see that the thing has been built. So actually into oil and gas, I noticed that this presentation setup doesn't show you your next slide. It's an interesting view of the world. Anyway, so yeah, SICR, it's enterprise DLT, but primarily we're about the templates and the tools. So at the lower level, you have a distributed network. You have cryptographic wallets and keys that allow you to perform cryptographic methods. We're still based on Bitcoin wallets, hierarchical, deterministic, but as you've seen with API before. But I guess the main thing is that Bitcoin itself doesn't actually do encryption. You've got keys, so you can use elliptic curve, Diffie-Hellman, and ECC encryption algorithms. There's a whole suite, which we use the Bouncy Castle suite alongside our wallets. But the point of this is to securely share sensitive data. Now, in this case, it's manufacturing data, but there are commercial sensitivities around suppliers within the chain. This has to be adaptable as well. This is not a straight linear, I make a thing, I sign it off, it moves to the next stage. If you've got a 40-ton wellhead that has to go out on the next boat on the next tide, but it happens to be missing a 20 quid rubber O-ring, which you can put on the next helicopter, technically your thing is not signed off, yet you've still got to move it. So we have to deal with punch lists, snagging lists as you might see them, with rejection of steps, sending things backwards. And this is all built into the streamlined, permissioned workflow. Chains of custody are actually applicable across lots of other fields. Obviously, with the identity stuff going on today, you'll hear about it in health and social ID and jobs earlier. But it's really about maintaining the confidence in the chain of custody of the documentation that we are interested in. So oil and gas. Finally, he starts talking about things that you can kick. Even within the manufacturing of something like a wellhead, which is effectively a big tap, there are a number of organizations that do specific steps within this. So at the top level, you'll have the oil companies themselves, license holders generally, even though back in the day BP would be drilling and doing the full process. These days, oil companies tend to hold the licenses and contract third-party companies to do the actual work. So already you're starting to get into a world where it's not a single organization. They come together on projects. There is a lot of flexibility in and around how these companies operate, how they set up, and the infrastructure that they need to implement these services. It's not just about the big things that you can kick. Actually, very much on the API piece and job-related activities, You've got people who are certified to do welding, to drill. There's so much certification around health and safety, particularly in offshore work, that a way to be able to share the information between these organizations, especially when you might be coming out just to do a single job. And there are some very specialist jobs in manufacturing, even down to very particular threads that are used for joints. It's quite an eye-opener when you get to go up and get shown round the factory that makes these things. Software engineering might be fun, but this is top quality engineering. As one of the guys said there, space travel's easy. All you've got to do is keep 1 atmosphere in. Deep water drilling is really hard. You've got to keep 1,300 atmospheres out. So it's a different order of complexity. So within this, obviously, these organizations, they need efficiencies, they need transparency, but they need to protect their IP. They need to protect their commercial organization from knowing who's buying valves from whom on any given day. The other thing is that SICR specifically was designed to be built for cybersecurity and provide some details of anonymous reporting. These are useful in the wider realm. Cybersecurity in the oil and gas is quite heavily dealt with as well. So it's a permissioned ledger. It's shared infrastructure, but I'm not sure it's such a major bonus in this field. So the very specific use case we're working on is with our partners, and this use case came to us via, I should also say, from the Advanced Forming and Research Centre, part of Strathclyde Uni. So this really came as a problem from the industry to us. Can you help us solve it? The partners included, or do include, Baker Hughes, General Electric. They are what's called a Tier 1 manufacturer. So they are the people that pull the assemblies together and build an actual subsurface wellhead. And what we are currently modelling is an H4 deep water connector. Weighs about 35 to 40 tons and costs the best part of $120 million. So high value manufacturing, absolutely, yes it is. And they produce about 5 a month as well out of Montrose. So little industries you don't know about, but are big parts of the Scottish economy. Included in that, as I say, a wellhead is effectively a big valve, a big tap. But within it, there are many subcomponents, about 40 or 50 valves, pressure controllers. This thing sits in really deep water, so it's made of incredibly esoteric materials. And even once they've got the metal cast and milled and made the tap, they then weld even more expensive material on the outside of it, and then paint it. And each of these jobs, whilst it might seem simple that I'm painting a nut, but this nut costs £1 million. The painting is very specific, the heat treatment is very specific, and all the records are captured. And this is how they do it at the moment. They have a nut, they have a standard poly pocket, as you would use in the office, and in it you get a sheet of paper, and every sheet of paper is the test report for the painting, the verification, the output of the measuring machines, the crystallographic, or whatever, the metallurgy photographs of the metal crystal. All this information is gathered and is attested to by Lloyd's Register, who's another, they're not actually in the tier system, but they are an assurer of the system. And certain information has to be passed to the next party, and all of the information has to be passed back to the tier 0, to the license holder, which in our case is Chevron. As I say, they've got to keep this paperwork for 25 years, and it takes up about 2 rooms in Iron Mountain. So for one wellhead, for one complete wellhead, it's about £2.5 million just to store the paperwork for 25 years. So it's interesting numbers. And what we're basically doing is facilitating the passing of these documents directly on the chain to the next person forwards and backwards as is appropriate, with third-party overview to tick that box and say, yes, I have checked that this thing has been painted and it is indeed painted. We're still going through the processes of working out how to roll this out, but there's a whole bunch of side benefits that have arisen really through just working with the actual businesses themselves. So this £2.5 million for storing the paperwork for 25 years, you know, we've got it digitally. You don't have to go into a Iron Mountain storehouse and pull out the paperwork. You can now correlate that we used a bell, valve, whatever the type is. They'll be produced in batches, and we can now look up where those batches of valves are. So if it was a case that it was a valve in Deepwater Horizon, we could find out where the rest of that batch went. This is a task that they currently cannot do without a lot of legwork. And from our initial calculations, we are looking for Baker Hughes that it will save about 3.2 to 3.4% of the cost of manufacture, just removing the legwork, effectively. The paper chasing, the legwork. I'm not even going to go in how they do non-conformities, because that's just stickers, red and green. Anyway, 3.2 to 3.4% of a multi-billion-dollar business. This is big numbers. And it's not the only use case in oil and gas. I mean, this is one that we are working on really specifically. Actually, at the bottom of the picture, you can kind of see the wellheads at the bottom. But there are lots of other use cases in oil and gas. Obviously, we've mentioned permits and certificates. Permit to work was the main cause, or the failure of a paper-based permit to work system offshore was the major cause of Piper Alpha, which was the year before I started working in oil and gas in Aberdeen. So using these systems, safety critical systems, to default to safe is very important. Again, this really has to do with, there's so many parties involved. The OIM, the Offshore Installation Manager, he's the guy who's in charge of the actual platform. He is the law, literally, out there. You've got third-party assurers, back to the DNVs, the Lloyd Registers, the people who have to attest, that word, that a thing has been built properly. Obviously, logistics, there's a helicopter there, but the number of supply boats that go in and out, the number of people that churn through these processes. Again, they've got to be certified, they've got qualifications, they might be coming in just to do a very specific job and disappear again. How do we quickly get them into the system, get them to do their job, and quickly get them offshore? Health and safety, yeah, absolutely. But it's down to control, it's down to how we can look at the data flowing, make sure we've got control points, make sure we get the right data into the right people's hands at the right time. So the value, absolutely. Digitizing processes, going from Polly Pockets with paper, I need a drink after that one, going from Polly Pockets with paper to fully digital systems is a stepping stone, because they're looking to the next generation of manufacturing, Factory 4.0, where and hopefully this will be the next phase of work, where the actual manufacturing machines themselves put the data directly into the data store, the blockchain, the SICR system we're building. It comes with a number of issues. But the way forward, particularly in very advanced manufacturing, additive manufacturing, is all about protection of IP as well. So it's good to see that these technologies can be used in a way which enables good working practices and gets rid of paper, really. But the bit for IoT is that we're starting to get rid of manual processes. We're starting to get rid of literally dot matrix printer printouts getting scanned into PDFs and sent around about the place. That data's not actually of any use for any greater analysis. Take the temperature readings of a heat treatment process and put them directly in, so we can start to do some analysis on the data sets. And I think there'll be some interesting data sets that come out. Again, we don't have ways forwards, or wasn't an initial business benefit that we were looking for, but as we're going, we're starting to see that there's lots of other spin-offs, lots of other benefits that can happen down the line with having purely digital data. We can see how the work is in progress, which is an important piece. Where is my wellhead? Okay, it's not quite a thing that you lose, but often these are very time-critical operations. Obviously, if boats have got to go out on the tide, then you need to know where things are. Generally, they're getting a police escort on the back of a low loader, but you know, it moves. Ecosystem collaboration, single source of truth. This is bread and butter to a blockchain audience. This view of the digital twin of physical jobs, I think, is one of the newer pieces that come out. So it's not just about digital twin of an asset, it's about digital twin of the actions that take place. And it allows, knowing that you now got automated processes, it allows manufacturers to, and assurers, to be able to take a much more, I don't want to say laid back, but a lot less intervention in the process. Because literally, as I say, we're often having Lloyd's assurer guys standing on a field watching a thing getting painted to say that it is being painted. And it's really about the full life cycle from the request for a wellhead to it being delivered. And I suppose a really important point here is because it's not a replacement for any of the existing systems. If you're in Chevron and you're buying a wellhead, then it's bought through SAP. That's your internal system for doing that. What is being built is defined by your quality management system. Again, it's a different thing. What we are doing is gathering the evidence so that by the end of it, we've got a useful, documented and attested description of how that asset was built. So that's the benefit that our customers are really looking for. That and the usual question, which is always the first question, which is how much does it cost and how much will it save me? That's the oil industry. So that's really me about the oil and gas. There's many other uses of data in the oil and gas space where the provenance, the integrity of that data is health and safety critical. You can look at it in other industries, and we're always willing to hear about other opportunities.
Fantastic. Round of applause. Yes, certainly, absolutely. We have time for one quick question. We're burning into our lunch time now. We started 20 minutes late, so this will be a bit of a readjustment. Don't give yourselves indigestion, but we have time for one question. No questions? Okay, thank you very much.
Thank you.
Great stuff. Okay. So up next we have securing DNS with blockchain. Pavlos.
You just clip it on up there and stick that in your pocket. Hopefully your font's embedded.